Hey everybody, Trey here. Welcome to another forecast discussion. We've got severe weather on tap for tonight as well as tomorrow, February 21st and 22nd. Tonight we have a slight risk stretching from North Texas through the eastern half of Oklahoma up into southern Missouri, northern Arkansas. Accompanying tornado threat with this setup, as well as a damaging wind and hail threat. And then tomorrow that shifts off to the east and southeast from southern Illinois, western Kentucky, all the way down south through the northern half of Mississippi with another tornado threat, as well as damaging wind and hail threats for tomorrow. So let's go ahead and get started. This comes on the heels of last week's severe weather event across the southeast. And pretty similar satellite image. We've got a nice trough building in across the west coast. You can see that kind of digging down here. Big fetch of mid and upper level moisture here, extending from the southwest up through the northern plains. And this is going to be our main player. It's going to be overall sort of just a big troughy kind of pattern. We're going to see this kind of long wave trough maintain itself for the next several days. And as that happens, we're going to get a couple different short waves to move through the southern plains into the eastern half of the country. And those are going to be the main players for the upcoming severe weather event, particularly this lead one out here. We'll talk about that in a second as we look at our upper air maps, but that's going to be the main player for tomorrow and Tuesday's severe weather event. Let's take a look at the surface. We have a cold front sitting somewhere up in here. You can see the wind shift, northerly winds here across Nebraska, far northern Kansas, switching to southerly winds across the southern half of Kansas. So wind shifts somewhere in here. So we've got kind of this cold front that's just kind of sitting there. And as that trough kind of ejects into the plains, we'll get surface cyclogenesis here out across just to the lee of the Rockies, somewhere in probably eastern Colorado, western Kansas, or just south. And as that happens, that will allow this, number one, this southerly flow to continue to ramp up throughout this afternoon and evening into tomorrow, and that cold front will begin to sag southward. And as it does, we'll probably see some storms fire along it in a line as it surges to the southeast. Let's take a look a little bit farther south so we can see where that moisture is. So we've got 60s dew points all the way up almost to the Dallas-Fort Worth area, kind of south of that line. Probably down toward the San Antonio-Austin area, up toward the Dallas-Fort Worth area and areas south. Already 60s to upper 60s dew points even here, kind of closer to the Texas coast. That is going to continue to surge inland today as we get that cyclogenesis to occur, and that cold front begins to sag south. Should see 60s dew points make it well up into eastern Oklahoma and Arkansas, and as a result, we should see the boundary layer moisten pretty nicely for severe storms this afternoon and evening. However, we are going to see a bit of a cap. You can see here, this is the morning Fort Worth observed sounding. And you'll notice here, pretty stout inversion here, situated between about 700 to 850 millibars here, maybe just below 850. Associated with some steep lapse rates aloft, likely emanating from the southwest. If we take a look at, let's say, here's Albuquerque. You can see some steep lapse rates here in the low levels at Albuquerque. Those have likely emanated from there, transported their way east along that kind of zonal flow, the east-west flow, situated in the mid to upper levels of the atmosphere right now. And it's kind of settled here across the southern plains. So this may be a little bit stubborn to erode today. Given that the shortwave is going to be fairly low amplitude, we'll take a look at that in a second. But the shortwave that's going to be the main engine for the severe weather event is going to be fairly low in amplitude. So that means the height falls may be a little bit tempered instead of this big sort of deep digging trough. These height falls may be a little bit meager, and as a result, this cap may be a little bit stubborn to erode. Hence, we are in the chance for surface-based convective development tonight is going to be in question. along in that slight risk area. But nonetheless, I think we do have steep lapse rates aloft, some instability already there. We will receive some surface heating throughout the day. If we look at our visible satellite, we do have some clouds across the southern plains, but those are moving off. Those are moving off to the east and northeast. Those should erode pretty nicely throughout the day, so leaving that kind of sunshine behind there. We should get some ample surface heating throughout the day today. So there is a chance that that cap will erode enough for surface-based storms this afternoon and evening. But would expect, given the strength of this cap, that with the convective temperature here of 87 degrees Fahrenheit, the cap will probably maintain itself throughout much of the day, leaving storm development to be pretty much after sunset. Let's look at our upper air maps here. This is the surface. Again, you see that cold front there stretching from Kansas up to the northeast. We go up to 500 millibars here. You can see kind of this more kind of zonal flow pattern here across much of the continental United States. A lot of west to east flow here in the mid-levels here at 500 millibars, but you can see this trough making its way across the western half of the continental United States right now. And if we go forward in time a little bit, kind of a little sort of peek into what the models are showing before we actually dive deep into the models, you'll see that it kind of stays that way. We're not getting this really deep digging trough that really is a high amplitude feature. It's going to maintain itself as kind of this low amplitude sort of thing. And we're going to see these short waves, and we'll go to 700 millibars here. You can kind of better pick out the short waves. So you can see we've got a couple right here, little kink in the isobars here. The main one kind of back out here, which are situated somewhere in there. These will kind of just rotate through this kind of broad long wave trough here, and these will have the opportunity to impart some forcing on the environment and help storms initiate as they encroach on the southern plains early this evening. So 850 millibars here. We'll take a look at our low-level jet. We do have somewhat of a low-level jet in place already. We've got kind of that low-level circulation here up situated in the kind of central to northern plains here. And as a result, we have this kind of southwesterly low-level jet here extending from Kansas all the way south through South Texas, kind of bleeding into the southeast states, Louisiana and Mississippi. But pretty decent low-level jet here, 30 plus knots of flow at 850 millibars. Going to help pump that low-level moisture up from the south to the north. And let's go ahead and start looking at the models. First, let's take a look here at kind of our source region for the moisture, since we didn't already do that. So this is the Brownsville sounding. You can see those steep lapse rates aloft here. Ample capping inversion here in place, associated with some pretty dry air here aloft. And if we look at a little bit farther to the southwest, to the west, let's look at Del Rio. Fairly dry in the low levels here. Fairly steep lapse rates, warm, dry air here in the low levels. So that 850 millibar wind from the southwest is going to pull this kind of air mass up toward the north. So this may allow that capping inversion to persist throughout the day. The fact that this is going to be advected toward the northeast on that low-level jet. So that may be a concern today as far as severe storms go, that we may have this cap stick around for a while until we can get that more moist air up into the southern plains. So that'll be something to watch for sure. But let's take a look at the forecast models right now. You can see this is 500 millibars on the 12Z NAM run, so hot off the press, the morning NAM run here. You can see again this kind of zonal flow, pretty zonal flow across the CONUS, continental United States, with this trough starting to dig down. You can see that kind of enhanced flow there on the backside of this trough. That's going to start to dig down as it goes through the day, but you'll notice we've got kind of the shortwave already in place here. Kind of over northwest Mexico here. That's going to kind of move off to the northeast, and that's going to be our main player. That's our little shortwave that's going to rotate through this kind of broader long wave troughing pattern. And as this encroaches on the region, I think by late afternoon we should get storm development somewhere out here in the Texas South Plains. And then by early evening, that will spread off to the northeast after dark, places like North Texas, eastern Oklahoma, and that will move off to the northeast. So we'll go through the day. That shortwave kind of moves off. We get a little bit of this kind of lingering shortwaviness, if you will, kind of through the southern plains, and it kind of ejects off toward the northeast here. And this is a look that always gives me pause when I'm looking at southeast severe weather setups. We have kind of this glancing blow from the forcing, very low amplitude, sort of more zonal flow at aloft, always seems to make some noise in the southeast as far as severe weather goes. Because when we get these real deep digging, strongly forced situations, oftentimes the forcing will be so strong that you'll just get a ton of storms to fire in the open warm sector. And from a chase perspective, that's not what we want. That kind of makes the mode quite a bit messier. And at least a good thing for the residents out there, decreases the tornado threat. But when we have such kind of subtle forcing as we do in this situation, that's always something to watch in the southeast, because if you have a pretty broad warm sector and you have just enough forcing to get a few storms going here and there, the storm mode will be discrete. And given the wind profiles that we'll take a look at here in a second, I think a tornado threat is definitely in play for these regions come tomorrow. Let's go down to 700 millibars here, and we'll take a look at the shortwaves here a little bit closer. You can see that shortwave here situated across northwest Mexico. That's going to move off to the northeast as we go through the day today. That's going to be our main player. So here it is kind of there. So a little bit of enhanced flow here, encroaching into southern Oklahoma here by late afternoon, early evening. This should help enhance storm development here by 0Z. And then we have this kind of shortwave that moves off. This is 12Z Tuesday. A little bit of a shortwave there and some enhanced flow with that. The thing about this may be the timing. So you can see this is at 15Z, so this will be at 9 a.m. tomorrow morning. You can see the axis of the shortwave is already off southern Illinois, western Tennessee, kind of Mississippi, Alabama border. And as that moves off in the afternoon, we may get some subsidence or sinking motion behind it, which, number one, could inhibit storm development altogether, except along the cold front, where storms are being forced as it sags southward. And the open warm sector may remain free of storms due to this kind of sinking air on the backside. We'll have to monitor that closely, but that could be a negative as far as, at least from a storm chaser's perspective tomorrow, may keep the warm sector free of storms, but we'll have to watch. Low-level jet here, 850 millibars. We already have, again, that kind of low-level jet in place, and that's going to strengthen throughout the late afternoon and early evening and into the overnight hours. You can see we've got kind of this broad, 30, 40 knot low-level jet here from East Texas northward into Oklahoma and northeastward into Arkansas, upward into the Midwest. Picks up as we go through the evening hours as that surface cyclogenesis occurs, and it really starts to ramp up about midnight here across the eastern half of Texas into southeast Oklahoma. So any storms that are ongoing in our surface base could be able to tap into this kind of strong low-level jet, strong, warm, moist advection in the low levels, likely large looping hodographs here, and the tornado threat would be maximized here probably around midnight and going into the overnight hours. And then that kind of lingers on throughout the day tomorrow, but again, you kind of see that low-level jet move off to the northeast with time. Still plenty of strong winds here in the low levels with southern extent here in Mississippi and Alabama, much stronger up here to the north across the Ohio River Valley up to the northeast. But it does kind of move off as the day progresses. Surface pattern here on the NAM. We'll go back here so you can see that cold front is situated up here in the northern plains, central to northern plains. Going to start to sag south. You see that surface low really start to develop here in southeast Colorado. Will allow that southerly flow to continue throughout the day, and that cold front will begin to surge southward. And as it does so, I think this is at 0Z, we will have the possibility to see storms fire up along that cold front to the north, but we do have this kind of broad warm sector here. So if we can get discrete storms here across the southern plains, you can see the moisture is kind of going to be arriving just in time, if you will. The 60s dew points get to the Red River by between about 18 and 21 Z on this model run here. And you can see it kind of meets that surging cold front, but a broad kind of warm sector here through much of the southern plains into the southeast here for tonight. So would expect as that shortwave moves in that we do have kind of this dry line out here, and sort of that as that moisture kind of creeps northward. So by 0Z, I think we should get storm development out here somewhere maybe near the Midland, Odessa area, just to the east of there, and along this kind of moisture boundary, kind of pseudo dry line there, up into central Oklahoma. So we should see storms fire. You can see the orientation of the boundary. Let me zoom in here and kind of get the southern plains sector. So you can see the orientation of that boundary kind of bent from the southwest, kind of bends back toward the north here through Oklahoma and southern Kansas. If we look at our shear vectors here, so take a look at the wind barbs here, you can kind of see where that boundary is, so somewhere in there. So you can see the shear vectors up here with northern extent are quite a bit more perpendicular to this initiating boundary. Cold front is back up here in Kansas. So anything up here that is discrete, or that does fire, has the chance to be discrete, while down here we may see a little bit more clustering or line segments given the shear boundary parallel bulk shear vectors here with southern extent. So let's take a couple soundings here. This is going to be at 0Z, so we'll start up here in kind of central Oklahoma. 60s dew points haven't really reached that area yet. And then we'll go down south here toward Dallas-Fort Worth, and then back here into kind of central Texas. So central Oklahoma here, you can see that is not a severe weather sounding at all. No instability whatsoever. So that may preclude storm development completely across central Oklahoma until that moisture really arrives. Now this is going to be North Texas, Dallas-Fort Worth metro area. You can see that capping inversion really sticks around, and with some dry air here associated with it. So a very stout cap here. Given the forcing, we definitely will see some storm development, but they will likely be elevated above this pretty potent stable layer here. Farther south, you can see the cap gets even bigger here. Even more pronounced capping inversion here. But steep lapse rates aloft and some instability, so we should see some storm development, but it will be elevated for sure above that stable layer early on at least. We get a couple hours later. This is midnight now. We'll go kind of into eastern Oklahoma, I-40 corridor, kind of near Sallisaw. We'll go back down south here to the Dallas-Fort Worth area. This is going to be again at midnight, and then farther south here into central Texas. So eastern Oklahoma, you can see the wind profile a little bit wonky here up in Oklahoma. I'm not quite sure why that is. I don't know if that is accurate. I'm not sure that's accurate at all. Let me try to take another sounding here. Let's see. We'll go toward the Fort Smith area and kind of see if that is accurate. Yeah, that's going to be a little bit more representative. Some convective contamination here. So we do see that we have some convection ongoing. Let me see if I can get a different one. Maybe just south of there, out of the convection. Sorry about this. It's kind of the game of forecasting. You kind of have to pick some areas with some better soundings here. A little bit of convective contamination here, but a little bit better. So again, these red bars here are indicative of upward vertical motion from a storm updraft usually. So when we pick soundings from these regions, oftentimes we discard them. But I think this is an okay sort of representation of the environment. So you'll notice here that we do have kind of large looping hodographs here, some turning in the low levels. There is a little bit of a kink in the hodograph here, some backing here in the low to mid levels. So that may be a concern. But we do have a large looping hodograph here. And we do see this inversion has kind of eroded pretty nicely here up in eastern Oklahoma by midnight. Now this may have to do with convection, but I think we will have a better chance of seeing that capping inversion erode with northern extent up into eastern Oklahoma, western Arkansas as the evening and overnight hours progress. Farther south, however, in Dallas, you still see that capping inversion really sticking around. But lots of cape aloft, elevated convection with a hail threat, but they will definitely be elevated. Tornado threat should be minimal down there up in North Texas. And as we go farther south into Texas, towards central Texas, that capping inversion even more stout. So expecting to see that areas with southern extent going to have that cap stick around a little bit longer. But right ahead of that shortwave here in eastern Oklahoma, western Arkansas, should be able to see that cap erode a little bit more. Let's go ahead a couple hours, get into western Arkansas here, see if we can see another picture of what it looks like. And you can see that cap does stick around. It is a lot weaker up here, though. So we do have a little bit of an inversion in here, but it is a lot weaker. So given these large looping hodographs, I think there is a chance for storms to become surface-based here as they move off into eastern Oklahoma and western Arkansas. But going to have to watch that closely. I think areas with southern extent closer to the Red River and areas south are going to have that cap stick around, and therefore the tornado threat will be minimized there. More of a large hail threat with those elevated storms. So let's go into the next day. Let's go zoom back out to our U.S. sector here. So we talked about this shortwave kind of lifting off to the northeast. Whenever you have this shortwave move off, and behind it we're going to get sinking motion or subsidence. So we do have this kind of band of stronger winds aloft here that does extend back into East Texas, into Arkansas, Louisiana, northern Mississippi. But the main shortwave has kind of moved off up here into the Midwest. That could promote sinking air behind it. Let's look at 700 millibars closely, see if we can see any sort of shortwaves in here. You'll notice there's our shortwave, moves off by morning up into the Midwest. And behind it, there is this flow that does extend backward. And, we've talked about this before, but when you have strong flow aloft, here's the surface. When you have strong winds aloft, that's pushing air away from a region. So strong winds aloft are pushing all this air off to the east. Well, the atmosphere wants to replace that air with other air. So what happens is you get rising motion. From just those strong winds aloft, that displacement of that air kind of acts as a lifting mechanism, because the atmosphere wants to remain in balance. So it wants to replace that air that's been pushed off with air from below. So we may have enough rising motion, or at least neutral motion, to not preclude storm development here across the open warm sector. If we look at our low-level jet here as well, it does maintain a pretty strong quality to it as it goes through the afternoon tomorrow. But again, you can see it push off to the northeast. Stronger winds here up into the sort of Midwest region, and kind of leaves Mississippi, Alabama behind a little bit with southern extent. If we go down to our surface map, let's go ahead and zoom in here. Let's go our southern plains sector here. This might be a little bit better. So you can see cold front sagging south into Oklahoma, cold air behind it. So this is 18Z Tuesday. So we've got our cold front back in here. And in these kind of broad warm sector events, we want to see little sort of prefrontal troughs as an initiating mechanism for storms in these kind of weakly force scenarios. And it looks like we may have a couple little subtle troughs here, potentially one out here. Little kinks in the isobars here. We have a little one out there that could get stuff going in northern Mississippi during the afternoon. Kind of becomes a little bit more pronounced as it moves off to the east here. You can see the small sort of kinks in the isobars here. So we may have a little bit of a shortwave trough there up in northeast Mississippi, maybe one back here toward the Mississippi River Delta. Again, we're looking for those little kinks in the isobars here. And you can see you kind of get that right here along the Mississippi River Delta. So we could have some very subtle sort of prefrontal troughs moving throughout the day, throughout the afternoon here across the southern portion of the risk area. So we'll have to watch that closely. If we do get enough lift, just enough lift, and when we talk about subtlety in the forcing features in the southeast and for southeast severe weather setups, that always raises an eyebrow because oftentimes, again, those setups are really overforced. The forcing is so strong down here that you often get a messy storm mode. But if we get very subtle forcing, like is what's being shown here, if it can, overcome that sort of subsidence on the backside of the main shortwave in the mid levels, then we could see isolated, more discrete storm development here across the southeast tomorrow. So as far as the moisture goes, you can see that where the cold front is, the northern extent of that moisture, probably far southern Illinois, far southern Indiana. You can see right there, that's the northern extent of that moisture. And then our cold front sort of pseudo dry line feature extending back into southern Texas. Very broad warm sector, low to mid 60s dew points here across much of the region. And so our northern extent of the severe threat will be where these 60s dew points terminate here, up in far southern Illinois and Indiana, western Kentucky. And we'll extend farther south into Mississippi. So let's take a couple soundings here. We'll go far south up ahead of the, just south of that sort of warm front, just east of the cold front here. We'll go one down here across northern Mississippi, kind of ahead of those prefrontal troughs there. We'll take a couple there. And then we'll go farther south into kind of eastern Louisiana there. So this is farther north. You can see meager instability. This is at 21Z Tuesday, which would be 3 p.m. Central Standard Time. Large looping hodographs here, so very much favorable for tornadic supercells here. Even though the surface winds are a little bit veered, you can see some evidence of that very strong low-level jet here. Large looping hodographs, very meager instability though, just over 600 joules per kilogram of instability there. Pretty skinny, and that was kind of one of the drawbacks of our severe weather event last week, kind of the mitigating factor for it. The instability was so meager and skinny that I think updrafts just kind of struggled to get robust enough to produce long-lived mesocyclones and tornadoes. We saw a few after dark in Alabama towards the Birmingham area, but Birmingham and Tuscaloosa areas. But this kind of meager cape is a little bit, could be a little bit of a mitigating factor up there. But if any supercells do develop, they would have the threat for tornadoes given this large looping hodograph. Let's go a little bit farther south into Mississippi. Kind of the same thing. Not quite as much of a look for tornadoes here. Not quite large and looping of hodographs here. Instability is quite skinny as well across these areas. And then farther south, much of the same, a little bit more instability, still kind of skinny, but with that departing low-level jet off to the northeast, the hodograph's definitely not nearly as curved and looping as what we saw up to the north. So let's go ahead toward 0Z here and see what we get. Let's go western Kentucky. Let's go northeast Mississippi again, and we'll go kind of southwest Mississippi there. So with northern extent, again, you see that instability pretty weak on this run of the NAM. This is interesting, though. Mississippi, northeast Mississippi, very much large looping hodographs here, and a little bit more instability. Lapse rates aloft, little bit concerning, but its cape is a little bit skinny, instability a little bit weak. This has downtrended a little bit from previous runs, but nonetheless, that hodograph very favorable for tornadic supercells if we can get right-moving tornadic supercells out of this. Farther south, the instability is a little bit higher, closer to those higher dew points, and we do see a little bit more, little bit less curvature in the hodograph, but definitely more than adequate for tornadic supercells down there. So, with southern extent, I think the instability will be stronger, given the closer proximity to the greater moisture. With northern extent, still adequate moisture. Instability is a little bit weaker though, despite having larger looping hodographs. So kind of an overlap here with the parameter space here. I think the better shear will be closer to the those stronger winds aloft, that stronger low-level jet. But the better instability, I think, is going to be down here, closer to these higher dew points. So there may be an overlap in here somewhere, kind of northern Mississippi into far northwest Alabama, that could see isolated discrete storm development, take advantage of that little bit higher instability, still adequate low-level wind shear for tornadic supercells. And given the storm mode, the very, very subtle forcing, if storms can fire in the warm sector, they will be discrete. They will not be messy in nature. So a little bit concerning here for parts of central to northern Mississippi, even into far southern Mississippi. It is farther removed from the forcing, but higher instability, large looping hodographs that are more than adequate for tornadic supercells is a little bit concerning for that region. But if we can get robust supercells development anywhere in this warm sector, even along the cold front, then we could see a tornado threat with those as well. So last thing we'll take a look at here is some convective allowing model runs. This is the 12Z HRRR run. Again, take these with a grain of salt, as these usually are wrong, but just gives us kind of a guess at what the radar might look like with this setup. So you can see storms start to fire here down by the Midland, Odessa area. By mid to late afternoon, they're definitely going to be elevated at that point given the very meager moisture. But once they move into the better moisture, they start to get a little bit more robust towards the Red River region here after dark. This is at 3Z. So just before midnight here, they really start to get robust. You can see they have some updraft helicity tracks with them, so these will be supercells out here, but likely again will be elevated. If we take a sounding in proximity to those storms, you will see that cap really sticking around there, despite the large looping hodographs. So lots of shear aloft, steep lapse rates aloft. There will be some large hail with these storms, but I think the tornado threat will be minimal with southern extent here. As we move on through the evening and into the overnight hours, let's take a sounding here ahead of those storms in eastern Oklahoma, and you can see just what we were seeing with the NAM run. The cap is a little bit weaker here across eastern Oklahoma, so any storm in eastern Oklahoma will have the chance to become surface-based. And given these large looping hodographs, there would be a tornado threat if they can become surface-based across eastern Oklahoma, northwest Arkansas. But again, with southern extent, I do think they will remain elevated toward the Dallas-Fort Worth metro area and the Red River region. Moving into tomorrow, you can see the stuff kind of move off to the north. That may be a mitigating factor up there as well with the northern portion of the risk area. Could have some lingering convection throughout the morning, but you can see the warm sector pretty much dry. And let me move over here to the southeast sector so we have a better look at this. So you can see as we go on, warm sector pretty clear. And then by 18 to 21Z, we get these kind of isolated beans here across western Alabama. These could be supercells. Again, I think the instability may remain weak throughout much of the day in this region. And then you can see toward sunset, we do get some more robust convective development in the wide open warm sector. And you can see these are have much more of a semi-discrete storm mode. So these would have the potential to produce tornadoes if this comes to fruition. So places like central and southern Mississippi into western Alabama, gonna have to watch that tomorrow. A little bit farther north, let's take a look at the Ohio River Valley area, the northern portion of the risk area. You can see all that storm activity move through in the morning. Maybe a mitigating threat for that region, but we do have the chance for some severe storms up there as well, despite the weaker instability. So the WRF ARW here. Let's go to Southern Plains. I think this will be the last one we'll look at. So this one is for tonight. You can see the elevated storms fire up in the Texas South Plains late this afternoon, move off to the northeast, and then kind of get robust between probably about 9 p.m. and midnight across eastern Oklahoma. Again, once this capping kind of erodes a little bit up here, these will have the best chance of becoming surface-based, whereas farther southwest toward the Red River, I don't think we will see surface-based storms at all. See more storms there along the cold front, and then by late afternoon, early evening, this model does fire isolated supercells here across central and northeast Mississippi, northwest Alabama, well ahead of the cold front. So that will definitely be something to watch tomorrow across Mississippi. If we can get just enough forcing to fire storms out there, they will have a tornado threat with those. So that'll wrap it up. Again, we have a slight risk out from the SPC today for far north Texas into much of eastern Oklahoma, including the Norman, Oklahoma area, Ardmore, I-35 corridor, up the I-44 corridor to Tulsa, Fort Smith, even including Little Rock, and then up into southern Missouri. Tornado threat with those. Again, I think tonight the main tornado threat will be with any storms that can get into that little bit weaker capping up here from eastern Oklahoma into northwest Arkansas. But we will have to watch down here toward North Texas to see if that capping is a little bit weaker than forecast. But I do think storms will remain a little bit elevated here throughout the event, at least tonight, for North Texas, kind of the Red River region. But up here, eastern Oklahoma, northwest Arkansas, going to have to watch for that cap erosion and more surface-based storms. Damaging wind and hail threat as well, steep lapse rates aloft. Even with the elevated storms, they will have a large hail threat given the steep lapse rates aloft. So then we move on to tomorrow. Once again, a slight risk for the areas that we talked about up into far southern Illinois and Indiana, western Kentucky, down through Mississippi, far northeast Louisiana. Again, with northern extent, I think the instability will be a little bit weaker. So up in here, we may have early storms that may mitigate the severe threat as well. But we may have development up here, large looping hodographs closer to the stronger flow aloft. So they will have a tornado threat if they can be robust enough. But I'm really eyeing down here in the open warm sector across much of the northern half of Mississippi, central Mississippi. So Jackson, Tupelo, Starkville, Louisville, up into northwest Alabama. The chance for discrete supercell development looks pretty decent tomorrow if we can get enough subtle forcing in the warm sector. I do think the storm mode will be discrete and they will have a tornado threat given more than adequate looping hodographs for right-moving supercells there. So definitely something to keep an eye on as we go into today and tomorrow. Keep your weather radios handy. This will be an overnight event for tonight. Tomorrow will be during the day, but if you're in any of these regions, keep your sources of weather information handy. Keep those weather radios on, and you'll make it out okay. So that's all I have for now. Thanks for watching, and we will see you in the next video.